Hello, welcome to our channel. In this video, we will talk about linear functions and their graphs. First, we will look at what we mean by linear functions, and then we will look at some examples and their graphs. So a linear function is a function whose graph is a straight line. Since the graph is a straight line, we call it a linear function. So the word linear comes from the word line. So by looking at a graph, we can quickly tell if the graph belongs to a linear function or not. So among these three, of course, this is not a straight line, the first one. So this is not a linear function. The second one is a straight line. So this is definitely a linear function. Again, the third one is not a straight line, it's a curve. So this is also not a linear function. Basically, any graph that is a straight line represents a linear function. So in general, a linear function has degree 1 or 0. So by degree, we mean the exponent of x. So by degree, we mean the exponent of x. Exponent of x is either 1 or 0. And we can always write a linear function in this form, y equals mx plus b, where m and b are some constants. So for example, a linear function would be y equals 2x plus 1. And they can be 0 also. Either m or b can be 0 also. So another example can be y equals 3x. So in this case, we have plus 0. We don't have to write that. b is 0 in this case. Or we can have m 0 also. When m is 0, that part goes away. Mx goes away. So we have just y equals 5. So all these are linear functions. And another commonly used format is ax plus bx equals c. So as example of that, we can have 5x plus 3y equals 10, for example. And if we like, we can quickly write this in the format y equals mx plus b. Because we can isolate y from here, we just need to subtract 5x from both sides. So that will give us 3y equals negative 5x plus 10. We want to isolate y. So divide both sides by 3. When you divide 3y by 3, you get y. When you divide negative 5x by 3, we get negative 5 by 3x. Plus when you divide 10 by 3, we get 10 by 3. So in this case, this is m, and this is b. So m is negative 5 by 3, b is 10 by 3. So that means these two formats, ax plus b equals c and y equals mx plus b are the same. We can always change from one format to another format. Let's look at more examples. It says, which of the following functions are linear? So for that, we need to check if the exponent of x is 1 or 0. In the first one, we have negative 2x plus 4. So we have x to the power 1. So this is definitely linear. In the second case, we have exponent of x 2, which is not 1 or 0. So this is not linear. In the third case, we have x in the denominator. So although it does look like exponent of x is 1, but we need to have it in the numerator. So we must have, if we write in the same line, it becomes 5x to negative 1 plus 10. So the exponent in this case is negative 1, which is not 1 or 0 again. So this is not a linear function. In this case, the exponent of x would be 1/2 because square root of x is x to 1/2 plus 10. So this is not a linear function since we have exponent 1/2, not 1 or 0. In the last one, now this is written in a little different way, but here you can again see the exponent of x is 1. And if you like, we can write in one of these two forms, y equals mx plus b or ax plus by equals c. So if you want to write in one of these forms, let's say the second form, we want to isolate constant on the right side. So basically you want to subtract 3 from both sides. So we have negative x plus 2y left on this side if you subtract 3 from both sides. And on the right side, you will have 6 minus 3, which is 3. So this is exactly of that form. So this is also a linear function. So when deciding if a function is a linear function, we need to check if the exponent of x is 1 or not, or 0. Right, so now we will look at how we can graph a linear function. Since a linear function is decided by 2 points, we need to find just 2 points and then draw a line through them. So generally the easiest points to plot are the x and y intercepts. So to graph a linear function, if you can find any 2 points like these two, then the graph will simply go through those 2 points. Then the graph will look like this. And like it says here, the easiest points to find are x and y intercepts. So if another line has x and y intercepts like that, then the graph of that one will go through those 2 points. Any 2 points are fine, but it's easiest to find x and y intercepts. So let's look at some examples. Here is the first one, graph the following linear functions. So we need to find 2 points. Let's do that in a table. So when x is 0, y would be 2 times 0 plus 1, which is 1. So this gives us the point 0, 1. When x is like negative 3, y would be 2 times negative 3 plus 1. So 2 times negative 3 is 6. Negative 6 plus 1 is negative 5. So that means we have the point negative 3, negative 5. So all we need to do is now plot these 2 points and draw a line going through them. So point 0, 1 is right here. And point negative 3, negative 5 is right here. So the graph of this function goes through those 2 points. It's a straight line going through those 2 points. So this is the graph. And of course, it can extend to both sides indefinitely. So this is the graph of this given function. Now, instead of using these points, we could also use the intercepts like it says here. So let's try that. I'm going to clear all this and try finding the intercepts. So we can do that in a table again. To get y-intercept, we put x equals 0. And we already know when x is 0, y is 1. So the y-intercept is 0, 1. This is the y-intercept, which is the point. The graph crosses the y-axis. And to find x-intercept, we set y equals 0. So put 0 here and try to figure out x. So to figure that out, we need to replace y by 0 in the equation. So y equals 2x plus 1. You want to solve for x. So subtract 1 from both sides. You will see negative 1 equals 2x when you subtract 1 from both sides. And then divide both sides by 2. So you get negative 1/2 equals x. So this must be negative 1/2. So this is the point negative 1/2, 0. So this is x-intercept. So this is the x-intercept. All right, so that means the graph must go through this point here. Negative 1/2, 0 is somewhere over here. So again, once we have these 2 points, we can quickly graph the function. It must go through those 2 points and it must extend on both sides. So this is how the graph should look like. Going through those 2 points and extending indefinitely. And of course, we can graph this function using a TI calculator or other tools like Desmos. Let me quickly show you how we can do this in a graphing calculator. So we go to y equals. So hit this button y equals and clear the function that's already there. And then we type in the function 2x plus 1. 2 times x, we can get x from here, plus 1. Plus 1, hit enter. And then that's a graph. So this is the graph, but looks like we have to fix the window. So go to window. I think the x values are fine, negative 10 to 10. Let's also use negative 10 to 10 for y values. Negative 10 to 10. So y min and y max are negative 10 and 10. So let's graph again. So this is the graph of the function. And you can use all sort of tools like tracing. So if you hit trace, and with the arrows, you can move along the graph. So it will give you x and y coordinate at several points. So here we have the next example. We want to graph this function. Again, the easiest way is to try to find 2 points. So let us find the x-intercept and y-intercept. So to find y-intercept, we have 2 times 0, because we are setting x equals 0, plus 3y equals 6. Then we have 3y equals 6, so y equals 2. So the y-intercept is the point 0, 2, which is right here. Let's find the x-intercept now. So for that, we are setting y equals 0. So the equation becomes 2x plus 3 times 0 equals 6. 2x equals 6 because 3 times 0 is 0. That means x equals 3 if you divide both sides by 2. So we have 3 here. So the x-intercept is the point 3, 0. That means the graph must go through those 2 points. So to draw the graph of this function, all we need to do is connect these 2 points. Again, instead of using the intercepts, we could use any other points. So this is all we have in this video. Thank you for watching. We will talk more about linear functions and their slopes and intercepts in our next videos.